Bresenham's line drawing algorithm. Here in this algorithm, what we have seen, we use the floating point number. Here, we use the floating point number for the calculation of this one. We use, when we calculate this one, it's used the floating point numbers to calculate the slope and to calculate the error term. So when we consider the floating point numbers, the calculations becomes slow. Okay, the execution of the algorithm or the program, when we convert this algorithm into the program, that we are going to see for the practical also, that you are going to draw a line with this algorithm, implementation of this algorithm. So in this case, when we consider the floating point number, the execution becomes slow. And to avoid this or to increase the execution time, here we, instead of floating point, we try to use integer Bresenham's algorithm. Okay, integers Bresenham's algorithm. So what changes are made here in the integer Bresenham's algorithm? In the previous algorithm, what we have seen that m is calculated with y, delta y upon delta x, which may be the floating point number. Why? It's a division. And another e is equal to that, also the calculations may generate the floating point number. So to avoid this, here e compensate for a non-zero intercept with this one. Instead of calculation of the e with the previous method, here it used another method, that e is equal to 2 delta y by minus delta x, and here these values are used to decrease or increase the value of e. Okay, now see how this algorithm works. The first thing is x is equal to x1, y is equal to y1, delta x is equal to x2 minus x1, delta y is equal to y2 minus y1, both are same. Only the difference that in the previous algorithm, what we have done, m is equal to delta y by delta x. Here m is not calculated, and using the m here we calculate the error term, m minus 1/2. Correct? Both may generate the floating point. So instead of calculating m here, the error term is initialized with different way. Error term is initialized with the different way, that is 2 into delta y minus delta x, so that it always generate the integer value. Never floating point is generated. Now again the same 1 to delta x, I ranges from 1 to delta s. Then set pixel x, y. If e is greater than 0, then y is equal to y plus 1. And only the difference that here, again the calculation of the e or initialization of e is done with minus 2 into delta x. And here, every time x is increased and e is equal to e plus 2 delta y. So this is the only change done here in this algorithm. So one example I am going to write here. Draw a line with the end pixel. Draw a line with end pixel 5, 8 and 9, 11. 5, 8 and 9, 11. So put the values here in this algorithm. So the initial values are x is equal to x1, 5, y is equal to y1, that is 8. Delta x is equal to x2 minus x1. What is x2? 9 minus 5, that is 4. And delta y is equal to 11 minus 8, that is 3. Calculate the error term. 2 delta y minus delta x. So 2 delta y means 6 minus 4, that is 2. So first initially the error term is 2. Here we require 2 delta x and 2 delta y every time. So 2 delta x is 8 and 2 delta y is 6. I set pixel E, X and Y. So initially I begin E, we calculate E, we already calculated. What is it? 2. What is initial value of X? 5. And the initial value of Y is 8. Now start with main loop. I is equal to 1. Then set pixel X comma Y. 5 comma 8. So see, it is not possible to draw 0, 0 to 11, 11. It takes so much space on the screen, and that's why I am drawing it raster from 5 to 11, 5 to 11 on the X and Y coordinates. Because if we consider 0, 0 to 11, it requires so much space. And that's why I have drawn here from 5 to 11, 11. So see here, the next one, after 5, 8, set pixel. What is the next? Check whether E is greater than 0. Yes. E is 2, means it is greater than 0. Then increase the value of Y. So I increase the value of by 1, 9. Then E is equal to E minus 2 delta X. Okay. What is 2 delta X? 8. What is E? 2. 2 minus 8, it becomes minus 6. And while X is equal to X plus 1, means increase the value of X, Y, and then E is equal to E plus 2 delta Y. What is E? Minus 6 plus 6, it becomes 0. It becomes 0. Next, I increase by 1, I becomes 2, set pixel X comma Y, 6 comma 9. So here whether E is greater than 0, no, E is equal to 0. So here Y remains as it is. Okay, we are not entering this loop. Why? Because E is not greater than 0. It is equal to 0. So we are not entering this loop directly. It comes out or start with X is equal to X plus 1. So it is 7. It remains 9 as it is, and E is equal to E plus 2 delta Y. What is E? 0. 0 plus 6, 6. Now I increase by 1, it becomes 3. Set pixel X comma Y, 7 comma 9. Sorry, I forgot to draw here. It is 5, 5, sorry, 5, 8. It is here. The first pixel. Second is 6, 9. Third is 7, 9. Okay. After 7, 9, again, next E is greater than 0. Yes, E is greater than 0. Its value is 6. So increase the value of Y by 1. It becomes 10. E is equal to E minus 2 delta X. 6 minus 8 becomes minus 2. Then end while X is equal to X plus 1. E is equal to E plus 2 delta Y. What is 2 delta Y? 6. So minus 2 plus 6, 4. Then increase the value of I by 1. It becomes 4. Put pixel 8, 10. Put pixel 8, 10. So what is this? 8, 10. It is here. Then after that, E is greater than 0. S. E is greater than 0. So increase the value of Y. E is equal to E minus 2 delta X. It is 8. So 4 minus 8 minus 4. Increase the value of X. And then E is equal to E plus 2 delta Y. So minus 4 plus 6, it becomes 2. Then increase the value of I. It becomes 5, which is greater than 4. So stop here. So these 4 pixels we got here. The first one is 5, 8. The first one is 5, 8. The second one is 6, 9. Third one is 7, 9. And this is correct. So what happens here? The X value, you can observe it is increased every time. And the Y value, it may or may not be changed depending upon the error term. Depending upon the value of E, whether it is a positive or negative, Y value is increased or not. If it is positive, then it is increased, otherwise not. So why it happens here? Because the line is not exactly at 45 degrees. The slope of the line is not 1. Slope of the line is not 1, and that's why it's not possible to increase X and Y every time. Only X is increased here. What is the slope here? Delta Y by 3 by 4, correct? Which is less than 1, means less than 45 degree. The angle of the line is 45 degree, and that's why X is always increased, Y may or may not be. Whatever the basic we have studied, in this way the algorithm work. So if I draw the line from here to here, it will be like this. Not exact points we get here. So you can try in opposite way also. You can take as a homework as M greater than 1. M greater than 1. So in this way also you can try as a homework. So for M is greater than 1, what we require? Y2 minus Y1 should be greater than X2 minus X1. So same you can draw 5, 8 and 9, 15. Okay. Take this 5, 8 and 9, 15. Okay. 7 divided by 4. So M greater than 1. So in that case what happens? Y always increase. X may or may not be increased. Why? Because the angle is greater than 45 degrees. So as I told that the X and Y coordinate, if we consider a 2D plane, in this way, it is X and Y. When we consider a quadrant, what we say? It is the first quadrant, second quadrant, third one, and this is fourth one. So in the first quadrant, X is positive, Y is also positive. In this second quadrant, X is negative, Y is positive. In the third quadrant, both are negative. X is negative, Y is also negative. In this, X is positive and Y is negative. When we consider a quadrant, these are divided into 4. In the same way, we consider octant also. Octant means again it is divided into 4 parts. Considering the line Y is equal to X, Y is equal to minus X. So using that here, if we consider the octant, then according to the slope, the line is drawn in that quadrant. If the slope of the line is greater than 0 and less than 1, okay, greater than 0 and less than 1, then the line is with this quadrant only. octant. In this octant only. If m is greater than 1, then the line will be here only in this octant. If m is less than -1, then your line is in this quadrant. X and y coordinates are in this octant only. If m is less than 0 and greater than -1, then here. If m is greater than less than 1, it is here. If m is greater than 1, it is here, and in this way. So octant, through according to the octant, the line is also, we can consider the line. Why? Because according to the octant or quadrant, the values of x and y are positive or negative. That is about the line drawing algorithm. So what are the advantages are here? Use fixed points. 5, 8, 6, 9, 7, 10 fixed points are used. Easy to calculate, only addition and subtractions are there. No square root, square, etc. is not there. In circle generation algorithm, we are going to see its square is considered in circle generation algorithm or required. Faster execution compared to DDA. More accurate and efficient. More accurate than DDA or efficient than DDA. But the disadvantage that drift away from actual path, line path, because if the line is not at 45 degree proper, then some points is not possible to draw the each and every pixel. So drift away from actual line of path causes staircase pattern. So that we have seen in the previous example. 6, 9, 7, 9, 8, 10, etc. In this way, staircase pattern it generates.